Okay, so we're back now. Now we are going to look at the biochemical breakdown. We are going to look at hydrolysis. Remember, in hydrolysis, we break with water. We go from big polymers into monomers. So for carbohydrate analysis, the polymer we are going to use, the substrate is for the reaction is starch. So we are going to use starch. Remember, starch is a huge polysaccharide. And we're then going to put the starch in here. This is amylase. Amylase is an enzyme that breaks down starch. And so we are going to put amylase in two of them and not put amylase in two of them. And then we will see where the starch breaks down. The starch will break it down into maltose. Okay, maltose is a disaccharide. That is not the digestion all the way, but we are only looking at part of it. We are just from the disaccharide to the monosaccharide will be another process with another enzyme. But right now, we'll just go from breaking down starch to disaccharide called maltose. So I'm going to first start with putting starch in here in all the test tubes.
Does it matter how much you put in?
Yeah, I have it already worked out, like how much I need. And it'll be in the lab worksheet that they do. Okay, so I have labeled the 4 test tubes, C1, C2, C3, and C4. The first 2 is not going to get any enzyme. So we probably should not see any breakdown there. So I am going to use deionized water as the control without the enzyme. So if you read your lab manual, you'll see I'm adding 1 more centimeter of DI water. Okay, and in this one, I'm going to add the enzyme amylase. All right, so I have 2 test tubes with starch and deionized water, so no enzyme. 2 test tubes with starch and amylase, which is the enzyme. And this is what happens inside of our body. And our body temperature in Celsius, remember this is science, we do everything in metric system. So in our body temperature is 37 degrees Celsius. So now I'm going to put it in a water bath that is 37 degrees Celsius. Now, I have kept the water bath slightly higher because when we open and close it, it might drop down, and I'd rather not have it go below 37. So I'm gonna take these test tubes. If you were in the lab, you would be bringing this over to the water bath, okay? And open the water bath, and then put the 4 test tubes in here. And then we generally give them about an hour to hour and 10 minutes for the enzyme to do its work. And then we are going to look for breakdown products. Now, what I have already done is I did the same exact thing that I showed you about an hour ago, and I have 4 similar test tubes sitting in the water bath. So we are going to pretend that an hour is over, and I am taking these out. So this is C1, this is C2, this is, C3, this is C4. Boy, that doesn't look very good. All right, and now we are going to see if there has been any breakdown or not. So in C1, we had starch and deionized water, nothing else. So if you guys remember from lab 3, the way we detect for the presence of starch is by putting iodine, okay? So I'm going to put some iodine in C1. Can I go?
Yeah.
So the color of iodine is kind of amber, brownish, yellowish color. And you can see, let me put a parafilm over it. All right, I can see what happened. This is dark, dark blue. So starch is completely present. So I'm going to now look at C3. This had the starch and the enzyme. So since we have let it cook for an hour, the enzyme should have broken down the starch. So if I add iodine, it should not be that dark blue. It may be a little bit dark blue, but some of the starch should have gone. And you can see the color. It's not turning dark blue. What the color that you see is just the color of the iodine. Okay? So with amylase, starch was gone. It had broken it down. Iodine only tests for polysaccharides like starch. It does not test for smaller sugars like disaccharides, like maltose. So this shows me that the starch here is gone. That means the enzyme broke it down. So that means there should be maltose here. Now how do I look for maltose? That's a different test. That's called the Benedict's reagent. And so the way Benedict's reagent works is to make it respond to the small sugars, I have to actually heat it. So we are going to boil it for a little while. So I'm going to add Benedict's reagent, 2 centimeters worth of Benedict's reagent. Okay, and then, so this is C2. This is where it was starch and deionized water. So I don't expect any breakdown. I don't expect any breakdown. I don't expect there to be maltose. If there is maltose, this blue color will become orange. It's not becoming orange. That's telling me that there is no maltose. That means it still stayed as starch. So without the enzyme, I could not do a breakdown. Now I'm going to add the Benedict's to C4, where I had starch and enzyme, and then I'm going to cook both of them. Okay? So now I'm going to put them in the boiling water bath. So remember, you always carry your test tubes in the test tube rack. You hold the test tubes with the test tube holder, and you let it go in there, and we let it cook for 3 minutes. Same with this one. Okay. And we'll wait for 3 minutes for it to cook. We waited 3 minutes, and I'm going to see what happened to the test tubes. So this one, whoa. This is C2. This is the one where we did not have any enzyme. So I'm going to move this over a little bit. Okay. So this is C2. This is the one where we had the starch, but we did not have any enzyme. So the starch did not break down. So when I put the Benedict, even when I had the Benedict cooking, there was no color change. Now look at the one where we had the starch and the amylase and see what happened with the Benedict. Okay, here we go. This is C4. Look at that. Ouch. All right, so C4. So with enzyme, starch was gone. There was no starch left, and there was maltose. And so we had orange color. Small sugar present, that means starch broke down. Starch absent, that means polysaccharide gone. Here, starch was present, starch did not break down because we did not add the enzyme. Here, there is no small sugar because the starch did not break down. Okay, so amylase breaks down starch. That was the point of this.